There's one last mechanic that we have to look at before we can get into design, and that's exporting. And this is kind of a complicated topic in that it forces you to start talking about packaging, and I am not ready to start talking about packaging. That's going to be a larger conversation around design. So all I'm going to say right now is that Go decided to implement something called packaging, which basically means that every folder in your source tree represents a basic unit of code, which is a static library. Now, I want to talk later about this design idea, this design concept, and ways of thinking about it. But what it means is that we have to kind of think about this idea of encapsulation a little bit differently. And right now, I just want to focus on the encapsulation mechanics. So I'm going to switch over to my editor, and we're going to be looking at this source tree right here. And I've highlighted example 1. And inside of example 1 folder, you see another folder called counters. So again, I want you to remember the idea of a package is that every folder represents an API. Hopefully an API that provides something. And from the compiler's point of view, each folder represents a static library that has to be compiled and built and then linked together. And so from Go's perspective, things can either be exported or unexported from that package or folder level. So code inside that folder has full access to everything. Code outside of the folder that's importing that folder or package into it will only have access to those things that have been exported. Now let's go ahead and look at the counters source code file inside the counters package. And this is a naming convention we do a lot. We'll talk about this again later. But normally, if you can't name a file for the name of the package, you're going to have probably other issues as well with that package later on. We'll talk about that around package-oriented design. Let's just focus on the mechanics. So on line 5, we're naming the package after the folder name. Again, that's another good convention. You want to do that. And what we've now done is defined a type named alert counter. And on line 9, what I really want you to note about the alert counter type is the first letter in the name. It is capitalized. And what Go has done, I think, is incredibly brilliant because it's trying to follow around the ideas of convention over configuration. And what it says is if the thing that's being named starts with a capital letter, then it's going to be exported from the package. Any code outside of the package will have access to it. If it's using a lowercase letter, it's unexported. It's only for internal use. Now, I'm trying very hard to stay away from the words public, private, and protected, because in an object-oriented programming language, that's a configuration way of doing things. And this really isn't the same as private and public. This isn't about the data. This is more about the identifier, the thing that is named, and I'm going to show you that. But now that this has been exported, I can go into the example package right here. And you can see this very long import path that I have, because we're going to be importing this package or library into this other one. We're going to say, hey, we're going to leverage the API from that counters package. That's where it's physically located on disk. Remember that import paths are physical locations on disk already relative to either your Go path for source, okay, so that's already been attached, or to your vendor folder if you have one already inside your project. So this is already a relative path. We're not going to be doing things like this. You're going to break other people's code. And we've got to be very explicit where it is on disk. And there it is. But now, because there's a capital letter associated with the name of this type, I can take the value of kind int 10, convert it to a value of counters.alertCounter, and we can start working with it. And notice that the name of the package also becomes the namespace for accessing everything inside that API. Okay, brilliant. But let's take a look at example 2, because example 2 also has a counters package. But in this version of the counters package, what I've done is I've said, okay, alert counter now will start with a lowercase letter. It is now unexported. That means now if I try to import that again, like I did before, if I try to import it and I try to use it, the compiler is going to say, no, Bill, can't do it because you cannot reference this identifier anymore. It's starting with a lowercase letter. But again, I really want to show you that this is not really private and public. And the best way to do that is to show you another example with code that we will not really be writing in Go. So let's go back into our counters package. What I want you to notice is that I've made the type unexported again. We can't access it outside of this package, but I have added a factory function called new. So it's a very idiomatic naming convention for factory functions when there's only one type of value that we will ever construct. But notice that new is constructing and returning a value of the unexported type. This is really not a good practice. And you might even say, well, why would the compiler even allow this? If it's unexported, then we can't access it. We can't create variables from it. Bill, you just showed me this. Well, here's the thing. This isn't really about data access. It's about name access. And so look at what I can actually do is I can access the factory function new, pass it that value of kind int 10, and the compiler is actually able to create a variable of the unexported type. Kind of crazy, right? Because the restriction is at whether our code, the code we're writing, can access that named thing or not whether the compiler can do anything. Now, if I did see this code review would stop because this isn't really good. You're not getting any level of encapsulation here, right? There's none. This is really more annoying than anything else. And your Go linter would catch this and fail it as well. Okay, let's take a look at two more things that are a little bit more interesting. And we're going to switch over to a package now called users. So here's our users package. File is users.go. And this time I have a type. And this idea of exporting and unexporting also happens at the type level. And you can see here that this type is exported. We have two fields that are exported because they start with capital letters. But we have one field that is unexported. That means that only code inside the users package can access this state directly. If you've got application code that's trying to access it, like during this construction, the compiler is going to say to you, no, Bill, you can't do this, because that is unknown. Really, it's unexported. But here's something that I think is a little bit more interesting at a type level. Let's go back to our users package and do a couple of things here. Let's create an unexported type named users, or user, with two exported fields, name and ID. And then let's create an exported type named manager with the exported field title, embedding user. So here's the question. We know that outside of the users package, I can construct a value of type manager myself. It's exported. I can even set the field title. But what's going to happen with user? I can't access user directly. That's a lowercase u. But remember something. Because of inner type promotion, I can access name and ID, not during construction, but after. So let's take a look at this code. Here I am constructing a value of type manager with setting the title field during construction. I cannot access name and ID during construction because that would require going through the unexported type user. But once I'm done with construction, I do have access to it. This is all very, very, very bad code. If I saw this type of construction here, code review would stop. These ideas of partial constructions always result in bugs. So if I saw this in real code, I'd be asking you to make that user type exported. However, this is something that you're going to be doing that's very common. You might have unexported types with exported fields. And one reason is because of marshalling and unmarshalling. Your unmarshallers and your decoders, they require fields to be exported in order to access them because that's the way reflection works. Yet you don't want the entire type to be exported because it's still data that should be unexported or internal to the package that's using it. So that you're going to see a lot of. But overall, what we're looking for are patterns that aren't really giving you that internal use that we're looking for. So this is all we're going to talk about today, right now, when it comes to exporting. We're going to be able to look at that first letter. We're going to know whether we have access to that named thing externally from the packages defined in or only internally.